All right, good morning. Thanks for having us here today. I'm going to cover a little bit around the business challenge that we're talking about before I pass it off to Abin to talk about some of the more technical bits. So first off, I'm going to get into a little bit about permitting. So for anybody who's applied for anything in the natural resource sector in British Columbia, we all know that the application process can be a little bit complex. The BC government, for very good reasons, typically wants to know the 5 W's and the how about what we're trying to do. So, first off, it's service navigation, finding out where to find the right application to apply for the particular activity that you're interested in. Secondly, we want to know who you are. So, BC Services Card is the de facto identity standard for the province, yet most of our permitting systems still rely on BC EID for digital identity. There's also understanding policies, acts, regulations. Of course, we have a lot of this with the various kind of permitting activities that we have. There's fee guides, fee processing, technical calculations. We typically want to know where and how and what you're up to. So there's a geospatial mapping component. So a lot of the time when you're applying for a permit, it's a collection of a lot of different activities from a lot of different tools to come up with an application that'll eventually get to a statutory decision maker in the province to make the best decision on how we use our natural resources in the province. So the organization for the province of BC that manages most of the permit application intake is called Front Counter BC. And kind of underneath that is Virtual Front Counter BC. For the most part, it's a collection of fillable PDFs, and we do have a platform that we're going to talk about a little bit today called our e-licensing platform that handles a lot of the application intake on behalf of Front Counter BC. We had done a bunch of user research around what are some of the problem spaces and where we can leverage AI to potentially gain efficiencies within the permitting process. And what we found out talking to not only provincial staff, but some of the folks out there in industry is that it's a time-consuming process. A lot of the language we use in some of our antiquated forms technologies is very difficult to understand. And it results in, a lot of the time we get incomplete applications, we get people that drop off before they're finished. The data quality is often suspect, and what the result there is that we've got a person that works for Front Counter BC that has to spend a great deal of time with the proponent to help them navigate the application process and figure out how to get the application completed so we can move it on to the statutory decision-making process. And of course, what we're talking about here today, we've got a relatively older piece of technology that is hard to adapt. So what we're doing is we're looking at bringing in artificial intelligence to help guide that process to get a quicker application time, higher quality data coming through the other side, and a better package before we pass that off to the statutory decision makers. So a couple of years ago, we did kind of a deep dive into this platform that we call Posse e-licensing, actually with the help of some folks at AOT. We did a deep dive into this platform. We've got about 130 complex intertwined workflows. We've got payment processing. We're generating about $500 or $600 million a year revenue flow through this platform. So we haven't quite made a strategic business decision and a strategic technology decision as to what we want to do with this platform going forward. So we're looking at AI as kind of a bridging strategy. So how can we work within the bounds of the current systems environment because we don't have the investment to go and modernize or transform this to really ease that user experience and again help get higher quality applications in a quicker amount of time, which in turn will spur on economic activity for the province. So with this system, we have things like the Water Sustainability Act. It's a 142 section document. Anecdotally, some of the folks we interviewed a blueberry farmer out of Comox, for example. They've got a 5-acre hobby farm. They're actually hiring consultants and professionals to help them through the application process because some of the language of this 142 section Water Sustainability Act is hard for them to digest and dissect. So this is where things like MCP tools and retrieval augmented generation with AI becomes very helpful for a user to be able to use natural language and ask questions about whether the Water Sustainability Act applies to their particular application. Some of the challenges and constraints, we've been at this for 7-8 months now. I think we're all kind of learning together when it comes to leveraging AI in business workflows, adopting MCP. So that's been a challenge for the team that we have. We've got a wonderful partnership with AOT, with Microsoft, and of course with our partners at Computronics who built the platform that we're working with in the first place. But working with a consortium before vendors has its own challenges, despite the fact that it's moving very, very nicely. We've got a proprietary platform. We introduced this in about 2003. It's a JSP front end with an Oracle back end. It's a proprietary data model in fifth normal form that we don't know how to access. So there's some accessibility issues with that. We haven't updated the platform in about 12 years. So there's no API accessibility to be able to wire something successfully from the Microsoft Azure cloud where we're working to on-premise. So it's been a fairly difficult road to get us to where we are today. But one of the things that this team is really good at, Matt, you started the common services team in the NRS, is looking at this. We're looking at a business use case, but we're also looking at building a common framework or a common toolkit for the next team that comes along that wants to integrate AI into the forms technology within Connected Services BC. So there's all those kind of interplay pieces going on together, but we're starting to make some good progress now with the help of some of our partners. So this is where we are going to pass it off to Abin to talk a little bit about the work we're doing. I heard the previous speaker talk about orchestration agents. So we took kind of a code-first agent approach when we first started this work. We realized that we're going to maybe back ourselves into some corners from a sustained perspective taking that approach. So we backed off a little bit and we've adopted the Microsoft Agentic framework, and working with our partners at AOT and Microsoft, we've developed this multi-agent framework with an orchestration agent, chat agent, policy agent, a form support agent, so that when the user is interacting with the chatbot along through the application, it can actually fill out radio buttons and fill out text within that application and help the user journey along and ease that process. So I think with that, Abin, I'm going to pass it over to you to talk through some of the technical architecture details.
Sure. Thanks, Jeff. So right situation, my audibility depends upon my height. So am I audible now? All good, right. So let's go. I feel I don't need an introduction. Abin Antony, Principal Architect at AOT Technologies, into this project from last winter onwards. Basically, when I started this project, we talked with Jeff and other counterparts who have done the user research, and we understand that POSI is very complex. POSI is a permitting application. It's very complex for a good reason. Because permitting applications, there are different type of permits, like water permits, hunting license, or mining permits, irrigation, livestock. There are a ton of them. And as Jeff told, it's around 130 workflows. There is definitely need a big architecture behind to lift it all up. So before I jump into my architecture, I would like to explain what are the rationales I took before architecting the system. Okay, so four main design rationales. Suppression of concern. There is no AI over here. It's like basic common sense. It's a complex, okay, sorry, okay. It's a complex system, so I really understand that we need to separate the concern between the content and the form action. What is the real bottleneck with the front counter BC intake team is like the intake quality of the permit application is very low. That's because there are a lot of information applicants need to understand while filling the permit application. And sometimes they don't know what it is, right? So they might type TBD or not available. I don't know about it. That makes the intake team to go back to the applicant to and fro multiple times to get the real information out of it. So what we are doing with the Agentic AI app is like we are making a chatbot sitting in front of that legacy app, which will communicate with our remote agents deployed in Microsoft Azure in a containerized way. It will reply with the answer depends upon the form. So I can explain that. So for that, first common sense principle is suppression of concern. Just distribute the responsibilities among multiple agents. That's number one. When we have multiple actors, we need coordination, right? Similar to any system, like, so if there is one agent doing the conversational details, explain the user about the system, other agent might need to suggest the user based upon your conversation or your user scenario, this is the action you need to take. Or sometimes system will take the action, means the agent will take the action and will clarify, based on your conversation, I have taken this action. So that number 2, orchestration. Third one is context engineering discipline. So what does this mean in Agentic AI world? We all use ChatGPT, right? We give prompts. Hey, this is my email, or look at my email inbox and go and find the best prioritized email for me, because they will understand the priority based on your previous user action from your inbox. That's how usually all the co-working environment does in the Agentic world, right? For that, we need to set the context. So the prompts, context, conversational history, memory, that makes the context engineering a discipline matter. So that was my 4th rationale. Last one, optimized token utilization. My friend Adam and Toolhai, they all speak about token usage, right? So in Agentic world, token is everything. That's what LLMs understand. So why it is important? First thing is money. If we don't use tokens correctly, you will spending up more money into that. Second thing, it will hallucinate. That means all LLMs has a working memory called max tokens or context window. If we max it out, they lose the historical information which you have. So we need to use the tokens optimizedly to make the memory correct to action towards the user queries. So that's the 4th rationale. So let's move to the next one. So this is the architecture. The previous speakers here, Adam and the stack log person, has explained what is MCP is. What I am going to tell here is like, these are the agentic system, like multi-agent system we have architected. What you see in the middle blue box, all our sub-agents. That means the first one is the conversational agent that does the conversations with the user. Means if a farmer asks, hey, I'm a blueberry farmer, I need to irrigate for 12 months, what should I do? Does the Water Sustainability Act applies for me? So he will give answers to the user like that. Second one is a form agent. Based upon the user queries, it will suggest, hey, on this farm, you have to act in an X amount of way. I will be doing a demo next, so we'll understand what we speak. Third one is the service policy. What the service policy means is like, if somebody asks that, hey, I need to dig a well, so agent will tell that, yes, you can dig a well. Okay, good. Which action you should take? You should select the purpose. What is the purpose? Purpose is irrigation. Now, finally, if he tells that I live in downtown Vancouver, so policy agent will tell, no, you can't dig a well in downtown Vancouver. I'm just giving a hypothetical scenario, okay? You can't dig a well in downtown Vancouver because as per the policies, you are not bound to do that. It will not work. Jeff, correct me if I'm wrong, might be in downtown Vancouver, we can dig a well. I don't know about that, but I'm just bringing up a hypothetical scenario. So as you see, this orchestration pattern is parallel. Means query will come, understand the context of the user, if he is logged in or if he already have a conversation before with his geolocation, it will suggest whether you are you perfect for this natural resource to acquire. That's what service policy does. And as I told in front, there is orchestrator. He orchestrates everything. That's what you are saying in the front. He manages that. Now we go to the backend side of things. As told, what we are doing is that there are certain calculations we are doing. The calculation logic sits inside the POSI. As Jeff mentioned, it's a legacy app, legacy complex app for a good reason. All the calculation business logic we can't access through API. So what I'm doing over here is that I install the MCP servers and the tool integration directly go to the backend database, because backend database has all the calculation metrics which can make it available through our front end. So first thing, for our pilot release, we are not directly communicating with the backend database because it's in network zone B. So what we are doing is that we are create an ETL, dump the data into our intermediary data warehouses, use MCP servers. I don't need to explain what is an MCP server. That's basically for the tool calling to the backend. Previous technical speakers have done a good job explaining what is an MCP server. One-liner, it's a tool calling mechanism for agents. So that calculation will be done to the front end by one of the agent, might be in the combination of form agent and conversation agent. So, and if you look at the front, you can see we are using an API endpoint. What is API? The front-end application, which you see down below, there is a JavaScript, that's a legacy app, that will communicate to the API in an HTTP, using HTTP protocol. And the messages are being passed through that API to the orchestrator agent. None of the agents are exposed publicly. And this is where we put our security guardrails and other kind of things. Yeah. So let's move on. These are our tool stack. So we use Microsoft Agent Framework. It's open source. That's our code first approach for building agents. Second, agent to agent protocol. Why? Because this agent talk each other, right? The first one that you're seeing over here is an orchestrator agent, need to speak with the conversation agent and the form support agent. Hence, we need a protocol. That's the global standard protocol for agents to communicate each other, make it discoverable, and even if we need to expose to other ministries or something, we can use that protocol. FastAPI, that's a Python-based API. We use FastAPI to expose our endpoint. That's what we're using in our API front end. OpenTelemetry. What is the significance of OpenTelemetry is like AI, people think it's a black box, but we need to do our best to make it explainable, right? What went wrong? Why agent has communicated back this matter to the end user, right? So we need the traceability, explainability, everything in OpenTelemetry. And since we are in Azure ecosystem, we are using Azure App Insights with OpenTelemetry. It has, and none of these systems deployed over here are it's agnostic to the platform. We can deploy the same template in OpenShift or Kubernetes or again in Azure Foundry. Anything will work. So, and OpenAI, that's our brain. Agent has brain. LLM is the brain. We use GPT-5 mini now. Model context protocol, tool calling protocol for that. Redis, that's the memory of the agent. Because as I told, the historical conversation matter a lot because it will allow us to use less tokens because some of the information has been already in process, right? So what we do over here in the system, you can see a Redis cache. So we use Azure managed Redis now, but it's adaptable with any Redis deployments. We store the historical conversation fed into LLM's brain, so it will understand, hey, this guy has already told he is in downtown Vancouver, so possibly he cannot dig a well. Yeah, let's get into a small coded demo. So let me pause over here. So this is what our application is. So this is that ASP.NET JSP combination legacy app. As you see, there are so much of content user have to divert outside to feel what need to be done. So I'm asking some more questions. What is BCID? People outside government or don't interact with government too much won't know about what is BCID, right? So I'm asking a question, do I need one to submit this application? So this is what the JavaScript, so let me explain that. So this is the legacy app. The badge that you see over here is the JavaScript injection we have done into this legacy app. And an API endpoint is communicating with our remote agents. This is only a small front-end piece. This one, it was not there earlier. We just injected it. And let's proceed. So this explains the reason you don't need a BCID to submit the water permit application. However, it explains if you have one, you can store the details and go home for some time because it's a 10-step application. As I told, it's complex for a good reason. People used to feel half need to save, so they need a login for that. I need to apply for, now watch this question. I need to apply for 2 permits, one for 6 months and other for 3 years. So, sorry, video is lagging for for 2 different farms. So that's what the question I asked. So it explains, yeah, for 6 months you need a permit, you need to go and apply somewhere. So what happens most of the time is like they enter permit applications into this app, and finally the permit engineer or the approving authority find out this is not the place that he need to submit. He need to submit in other app. So this way we can communicate with the user and tell that, hey, you can go there and apply for that farm, you can apply there. For this farm, you can apply here. Let me just fast forward a bit. So this is another thing. It is telling what is this screen for. Robot, what should I do here? It will explains why we need that. Yeah, if you're applying for a permit, be aware that verification step. Just again fast forwarding. The verification took way longer when I recorded this video. Sorry for that. Now let's take a pause over here. So here you will see another action by the agent. So this he is checking this is eligibility screen, whether he is eligible for a water license or not. You can see radio buttons, but there can be a reason he is eligible or not. What in this demo, in this section, you will see whether based upon his context, which he entered earlier, agent will automatically go and select the option for him. So I own my farms, as I told, blah, blah, blah. So am I eligible or not? So he checked his previous context on the conversation, and agent go and select the radio button. It's not human clicking the radio button. Agent will automatically select it. Yeah, it's selected. And explain to the user, scroll down. As a farm owner, yes, you are eligible. Please confirm eligibility. Yes, I have selected yes for you. Yeah. So there are again complex steps inside, like in calculation, it will understand how much water you are going to consume in a year, and based on that, it will do the manual calculation behind the scene and ask, are you agreeing with this estimate? Then we'll go back. Oh. Yeah, that's the demo. If you have any questions, I'm ready to answer. Yeah.
So in this example, the agent is interacting with the form, with the user's authenticated context of the BCDA
Yeah.
session.
Authenticated and unauthenticated as well, both. Yeah.
And then what other kind of audit is there other auditing that's done about that conversation?
Yeah. So there are
MCPs?
there are two level of auditing happening. One is with the chat, what has been come inside and what has gone out. That's from the agent side. Okay. Now we know that there are chances for prompt injection. People will spoil because this is a public app, right? Anybody can spoil anything. So I know your question is regarding with the. Let me go back to the architecture diagram so it's easier to explain. So what we have done over here is that you see this API. This is bound to the WAF, Azure WAF, Web Application Firewall, and we have guardrails attached to it. So it will sniff all the prompts or the user instruction coming up and see whether there is any override kind of instruction inside that. That's number one we are doing from application side. Number two, there is other red teaming effort. So the LLMs which we use inside each agents are hosted inside BC Government's Azure AI Hub. So inside at the model level, there is another red teaming. We can put the content filters over there, and we don't store any personal information. Some layman users who don't know, they might enter that's what our intake team has told, they enter the credit card number. very sensitive information, which we are not about to store inside ourselves. So we take it out and store inside our OpenTelemetry. So to your question, yes, we do guardrailing at the API level and also at the model level. Yes, we do that. Yeah. Yeah.
In that example, did the AI bot actually submit the application, or is that just a guided example?
Oh, yeah. So this is a guided example. We need the human in loop. So the whole purpose of this agent to assist the user. As you see, this application is complex in terms of content, right? So it
Get to the point where you open the assistant, you say, I want to apply for a water permit. The AI assistant asks you a bunch of questions. You submit that information, and it applies on your behalf.
we don't apply the submit. Last final submit will go from the human. AI bot will not do that, because you can see that's a good question. We don't enter any kind of sensitive information from bot. Bot will only suggest, but certain areas we understand as per our user research from the users. There are certain areas we marked as in our heat map that this need more assistance for the user. So there we go and select. Calculation, we will make it review for the user. Certain areas we need there is a geolocation map submission. I'm not demoing that today because it's too complex. It will take too much of time. But there are niche areas that we need to open another app, draw the map, and come back, which we will suggest and guide them how to do that. Yeah. Yeah. So no submission. Always human is required. We are not here to eliminate the human presence. Yeah. Yeah. Thank you. Oh yeah. One question.
This might be a question for Jeff. I'm not sure or if you have the answer as well, but the principle of collecting information only once, one of the ones we're striving for, with your chat, is if they've already submitted a previous water license or they've sent some information in a related water license, do you have tools, MCP server, that can pull from previous locations to help autofill are you able to collect consent to, hey, I can go and get your previous license information with your consent, or is that in the scope of this, or?
Not yet. It's something we're looking at. We have a system called the authorization tracking system that tracks all the intake applications over time. So the goal would be, another thing we're working on right now is the user has to swivel chair the water irrigation calculated, get a slope and elevation on their land, and we're also working on developing an entity involved with that. So yeah, that's absolutely in the future, the one's kind of strategy to go with past data, bring that in, and then build out a form for when it comes back. I think we probably want to fix identity before we do that. Everything needs services started on identity.
Yeah.
Yeah.
Oh, good.
Thanks.
Thanks, folks.